Number 5, find dy dx for each of the following. Again, we'll use good notation all the way through. So dy dx here equals, okay, the derivative of a number to a power, or a number to a function, is the number to the function times the derivative of the function, so the derivative of 2x is 2, but then finally times ln of the number, ln of 5. It's like the e to the x rule, but you don't have to stick on ln of e at the end of that because ln of e is 1, but here you have to put ln of 5. And we'll just leave it like that. We're not going to simplify any of these. dy dx equals. Okay, here we've got a product rule. First times derivative of the second. Derivative of inverse tan is 1 over 1 plus the stuff squared times derivative of the stuff plus second times derivative of the first. Derivative of x minus 4 cubed, that's a chain rule. 3 comes down, copy the stuff, subtract 1 from the power, times the derivative of the stuff in here, which is just 1. Part C, another chain rule. Here we have ln of stuff. Good notation. dy dx equals ln of stuff is 1 over the stuff times the derivative of the stuff. No quotient rule. So we're just doing the derivative of the stuff. E to the x squared. The derivative of e to the x squared is e to the x squared times the derivative of that stuff. Derivative of x squared is 2. Now we're ready for the derivative of cosine, which is minus sine. And finally, part D. You are welcome to try to solve this equation for y. It'll be messy because it'll have a plus or minus when you take the square root. But there's a really big tip off here. If your x's and y's are all kind of mingled together like they are in this case, implicit differentiation is going to be easier. So we'll take a derivative of both sides with respect to x. Derivative of x squared is 2x minus derivative of y squared is 2y. But then don't forget, y is a function of x, even though it's not explicitly written as such. So anytime you have a derivative of something with y, you stick on dy dx. That's the chain rule. Equals derivative of 2x is 2. And now we just have to solve for dy dx. So we'll subtract the 2 from both sides, move the dy dx over, and finally divide by the 2y. So that's just a little bit of algebra. May as well clean that up a little bit by factoring out the 2. So that's our answer, x minus 1 over y. The answer you would have gotten if you had been able to solve for y explicitly would look different, but would be equivalent to what we've got here.